Hey everyone, Brian Beeler and Kevin O'Brien coming to you from the Storage Review Lab. And today we've got a special guest. We're taking a look at one of the leading object store storage providers for Kubernetes, and that's MinIO. And I want to go ahead and bring in our good friend Daniel. How are things over at MinIO?
They're pretty good. Thanks for asking.
Good. So I know you had an announcement recently, a bunch of new features. You're continuing to build out the stack there. Give us a high-level intro to what you're doing.
So recently we made the announcement about all the new exciting improvements that we've made to the MinIO operator, right? So we're betting big on Kubernetes because it has become the standardization method for the internet, right? So now you can have the same experience on the public and the private cloud. So we see great potential on that degree of automation that Kubernetes brings to the table. And MinIO being software defined is the perfect fit for a Kubernetes deployment. Right now, you can build very large, very high performant object storage clusters on Kubernetes without much effort, right? Additionally, we announced Subnet Health integration, right? That's one of our services where we can actually help you understand, debug your own infrastructure. If you're having any problem with your MinIO deployment, you can bring a health file into Subnet, and we can pretty much visualize that and help you understand what's going on over there.
All right, well, let's take a peek at that just in a second. Kevin, one of the things that I know we talk about a lot is this new world of containers and the future of how applications are deployed. And for guys like you or me, or maybe both of us that are really rooted in the traditional enterprise storage stack, this whole world of Kubernetes can be a little confusing.
Yeah, although there are some points that help ground us. I know they talk about some really big performance numbers. So there's a connection between there where you still need to host this stuff. It still sits on the same type of storage. It's just leveraged in a different form.
Yeah. So when you think about the customers that you guys deal with, Daniel, and they're thinking about storage in a whole different way. And you guys have taken, to Kevin's point, some of the traditional ways that an infrastructure guy would think about something like object storage and presenting it to applications. There's just a bridge there that needs to be addressed to make things easy to consume.
Yes, and that's something that we've been that's been our priority since day one. Building something that's very easy to understand, easy to orchestrate. So even we're trying to give power to the developers to say, okay, this is the type of storage that I want for my application, and I can even take MinIO binaries, being such a simple binary, and running on my own system, develop my application, and no one trusts that I can scale this same binary to multiple petabytes at very high scale, and very easily, right? So that's very important. We're trying to make it very simple for everyone.
All right. Well, no one wants to listen to us talk all day, so let's get into show and tell here and take a look at what's new. I'm going to switch over to your screen share. So I know you're starting out with some high-level concept here on how it is that you guys work, right?
Yes, I'm actually going to be showing you a demo of the MinIO operator running on top of Kubernetes, right? And the way we are proposing people do this, right? It's bring your Kubernetes cluster. It doesn't really matter which flavor of Kubernetes you're picking, right? And then bring some local storage, right? So we recommend locally attached volumes, so you can leverage all those Kubernetes nodes that you have and have mixed workloads if you like. But additionally, we can work with any other CSI provision persistent volume, right? So we don't have any distinction on that. So any Kubernetes cluster will work, right? So whether it be Rancher, right? It could be vSphere, right? 7.0. So on top of that, you can deploy MinIO operator, and that comes with a family of servers. And the whole idea is that now you can provision multiple tenants, right? So this is what essentially I'm doing in this diagram, showing once you deploy the MinIO operator and its peer services, you can provision multiple tenants of different capacities, right? So now you can service either different business units within your organization, or you can also service different teams, as well as multiple customers, right? And every customer has a different need, right? Some need encryption at rest, some guys need access control via identity providers. So that's something that we want to make it easier, right? So you can cover every case, and while being the owner of the infrastructure, you have a really nice experience of deploying and rolling out this solution.
Right, and you guys support all the clouds as well, right? EKS, GKE, AKS, all the big guys.
That is correct. We went to great lengths to keep things generic, right? So we are not tying it down to a specific release. So when I was mentioning we will work with any CSI, you could easily bring this to, for example, Google Cloud and deploy right? Cloud brings its own CSI that provisions the local persistent volumes. If you go to EKS, the CSI driver will provision you EBS volumes. So we keep things generic, right? So you can always pick your own Kubernetes, the one that fits your needs. And usually that's part of the hybrid cloud strategy, right? You do some deployment on premise with some distribution, perhaps Rancher, and you're also scaling operations to the cloud, perhaps EKS, right? So you want to mix and match, but you want to have a consistent experience in both situations, right? Both private and public.
Okay. Well, let's get into the demo here and see how some of this stuff works.
Sure. So what I'm going to do first is, so not only we build an operator, right? So we also build a really nice user interface. And what we wanted is users to actually be able to interact with the operator in Kubernetes, but with a browser. So by starting, I'm going to start the demo by actually logging via an identity provider, right? This is just to showcase support for open single sign-on type of solution, but of course we also support Active Directory.
See, and this is actually one of my favorite parts already, because we've done this before, right? When we've looked at some of these solutions and they're all CLI, and I know you don't care and you're like, oh, that's cool, whatever. But I look at it, my eyes start bleeding because it's just been too long since I've had to play around with that level of management. And so when you talk about single sign-on, when you show a GUI, I know you've got the console update, which has a GUI for management and cluster controls. I mean, that stuff is music to my ears as an old guy that's not used to CLI.
No, yeah, and I mean, we don't have any problem with CLI. For many years, we provided a great CLI to scale things. That's the best way to build automation. But we understand that we humans are visual, so we enjoy watching things, and it's easier to understand them. And actually, here, after going through the single sign-on, I get a list of tenants, and I was telling you, different tenants can have different capabilities, right? And actually, the best way to understand what's a tenant, right? It's going to be creating one. And that's pretty much the next part of my demo, showing you how we create a tenant. So here, before I go into that, just want to point out, I have already 2 existing tenants on this setup, right? I provision production storage that I actually made 56 gigabytes in capacity. This is backed up by SSDs. And I have a 1 terabyte, right? This is sort of like a toy setup. I'm actually running this off of Google Cloud. But again, we don't make any distinction about where you're running your Kubernetes cluster. So now let's get started with provisioning an object storage. Let's say I have a use case to store perhaps some backups, right? So I'll be making an object storage so my organization can store some backups. So I can say, well, this is going to be my backups storage, NA West, right? So that's the first thing. We're going to say, okay, name the object storage you're about to provision, and then tell me the Kubernetes namespace where you want to place it. So it's important that we ask you what's the Kubernetes namespace, because we want to understand if you have any resource quotas imposed on that namespace. So perhaps when I logged in, I only have access to a certain number of namespaces within Kubernetes. So we want to be able to say, okay, which namespace you want to pick, and then we'll tell you which storage classes are available, right? So
on the on storage class specifically, are you able to take a step back and just kind of go into how the storage is set up, and or if that's more under the hardware technical setup part of this, kind of before you get to the stage of deploying tenants, more of a how you get this up and running on a given hardware setup?
So the storage class story, traditionally you will collocate compute and storage, but then Kubernetes presents a brand new paradigm where you're treating your infrastructure as code. And ideally, you want to provision your storage separate from your compute, and in a way that you could be using locally attached volumes. And what that means is that you are telling Kubernetes, when the application runs, I want the application to run next to the volumes because they're local. But additionally, there's providers, right? So there's some on-prem providers that make legacy solutions such as NAS available via CSI drivers, so that when you request a persistent volume, it's actually dynamically provisioned that NAS solution and mounted into your pods. So we work with both approaches. So as long as Kubernetes is able to provision storage in any mechanism, we will work fine. And additionally, another advantage of the storage class is that they let you group things. So let's say you have 3 different types of storage classes. Let's say you have, in some servers you have NVMe, in some servers you have SSDs, and in some other servers you have spinning drives. So the fact that you can place them on separate storage classes also lets you, when you're provisioning the tenant, you can pick, okay, I need some extremely fast, high-performance storage. So I'm going to pick this tenant to use NVMe drives. And then perhaps my tenant, for example, here is for backup. So perhaps I don't need my fast storage class, which is actually backed up by SSDs in this case. I can use just standard, which is hard disk drives that are spinning, right? They are slower, but they are more dense, right? So, and they're actually cheaper as well. So
sure,
I can.
Yeah. Let's not use NVMe for backup.
Okay. Yeah. Yes. Let's not use it. So yeah, and that's why we start with this, right? If you see this process of setting up the tenant is about asking you. If we go to with the simple setup, it's just asking you, okay, tell me the tenant and what the storage class that you want. The next question will be size, right? So you can see here on my list of steps is just, let's just size the tenant and that's it, right? We can keep it simple as that. For demos, I actually go through advanced mode, which adds 4 more questions just to showcase all the other things you can control and how easy it's actually to configure them. So if I go to the next screen, like one of the basics one is we ask you, okay, you want to use a custom image, right? So this is if you want to use a private Docker registry, or perhaps you're deploying to an air-gapped environment, right? And that's a situation where you will have a private Docker registry, or you want to just pick a hardened image of MinIO, right? You want to say, use this one version that right now my organization is very comfortable using because we battle tested in production, and I want this other tenant to also have this version. So we provide you an easy way to pretty much say, this one tenant I want with this image, right? And additionally, because it's a cloud instance, I can control whether I want via Kubernetes services expose this tenant immediately to the internet or I don't, right? Perhaps I don't want to expose this to the internet and I want to do it either only consuming inside Kubernetes, or perhaps I want to configure the ingress myself later on. Like those are things that you could configure in this screen. So the next part is the first part I showed you in this demo. I was telling you, right, securing access, right? It wouldn't be as nice if I'm using some JWT token from a service account in Kubernetes to log in, right? Like in the enterprise, right, you're usually using corporate directories to control access to applications. So here we actually offer you, okay, you want to use MinIO's built-in open identity provider, right? This is where MinIO will offer you accounts and groups. Or you can also bring OpenID for single sign-on type of solutions, the one that I showed you at the beginning. And you can also bring Active Directory, right, which is also extremely popular in the enterprise. Of course, Active Directory, you can already see it has way more options to configure. We're only trying to highlight you, okay, you only need to bring these 4 values, right, to make it work. But OpenID being simpler, these 3 questions, that's all you need to answer. But we're pretty much guiding you. So you're no longer having to write, technical configuration files just to get some object storage up and going. We're trying to make it extremely simple and quick. So then the next part is talking about security. By default, we turn on TLS. So we want to secure all the connections. And we manage certificates for you. You don't even need to install any additional components. We use Kubernetes certificates and in requests. That's inside the cluster itself. But of course, that way we secure all the communication. But we also support terminating TLS. So you can bring your own certificates, right? You can bring your own certificates and terminate TLS at MinIO side. Additionally, perhaps you don't want us to manage the certificates for the internet communication. You want to bring your own certificates. You can do that, right? Turn off our management of certificates internally, and it will work, right? This is very popular with financial institutions who like having a very tight control of every certificate that it's been using around in their own internal applications. But for this demo, I'm just going to go with AutoSer, right? I'll let the MinIO operator take care of all the certificates. Now, it's very important because now we have established a secure communication channel, and we can talk about encryption at rest, right? So if I want to enable encryption at rest for this tenant, because let's say I want to encrypt my backups, we support the 4 most popular KMSs out there: HashiCorp Vault, AWS KMS, Gemalto, and Google Cloud KMS. And again, it's the same story. We're trying to make it extremely simple by telling you only need these 3 values: the endpoint, the app roles ID, and the app role secret. But of course, HashiCorp Vault, for example, has a bunch of extra parameters like mutual TLS, retry, timeouts. These things you can configure in this screen. Like if this is the one thing that you want to enforce, right? So as the owner of the infrastructure, if you are providing object storage for a business unit or a customer, you can make sure that you enforce things such as access control via identity providers and encryption, and then you will delegate the management to them. And that's the next thing of the demo, where I'll show you actually how to delegate the management. So
I assume too, as you go through this process and create these tenants, that it's easy to replicate or clone them in case you're going to set up several of these types of tenants?
So we don't have a mechanism to clone them per se, because perhaps every tenant will need its own encryption keys, for example.
Right.
But we do have
point.
We do have enough. We support replication, both synchronous and asynchronous replication, and that's another thing we can touch on. But essentially, through the management console, we'll show you in a moment, setting up a synchronous replication. It's also like pretty simple, right? You tell us, I want to make sure that certain number of pockets are replicated in a synchronous fashion, and we'll just turn it on. So and the whole idea is, again, letting you get all those nice features that MinIO already provides, but in a visual way, and we want to help you discover them, right? So you can see any of these KMS that we support, but of course, we support any other KMS that's KMITS compliant. But yeah, that's pretty much the idea of these interfaces.
Okay, great.
So, I mean, after encryption, we reach the same screen, the step that I skipped at the beginning, right? So I'm getting some extra fields, but I'm now asking you, how big do you want your object storage? So here, because my demo instance is only 4 nodes wide, I'm getting the proposal of 4 servers. But let's say I'll be giving you something. Let's imagine that I could provision, like, I have 16 attached volumes, and let's say I have 32 servers, right? A very large number. I get an error because I don't have that many servers, but let's just, for the sake of example, say I'll be provisioning a tenant that is this large, right? For backups, perhaps I'll be doing 100 terabytes of capacity. I can pick up how much memory I want to have on every Kubernetes pod, right? So that's another thing that we expose for you to control. And then we can pick the parity value. So the ratio coding parity is actually how MinIO protects the data, right? MinIO already takes care of protecting the data against individual drive failures and node failures by doing a ratio coding on every individual object. So here we ask you this, and some users might be confused of what does that mean, right? How does that affect me? So in this case, by scrolling down and getting a preview of what's the infrastructure that we're about to set up, we also get an infrastructure of what's the amount of data that I'll be able to store in this setup, right? So for my EC8 value that I set up here, I can see that I'm also provisioning 100 terabytes of raw capacity. That's going to yield me only 50 terabytes of usable capacity, right? So the ratio coding is actually going to take some of that raw capacity. But because I'm doing this 32 server setup, that means that with parity 8, which is very high value, I can still tolerate 16 server failures. That's half of my servers can go down, and my data will still be accessible, right? So it gives you an idea of the type of SLA that you can provide to your customers in turn. But of course, we said this is a tenant for backup, so I can play actually with this picker, right, and say, well, perhaps I don't need that much parity. I need probably less parity. Let's go to EC4. How does that affect me? So we can see that for the 100 terabytes, that yields 75 usable.
Oh, there you go. Yeah, capacity. It updates your usable. Yeah, you know, that's a really useful visualization because Kevin, I don't know how many times we've gone through cloud provision things, and you can pick the instances and tell it how much you want, but it doesn't normally show you.
Yeah, the disconnect there is sometimes a little bit jarring to where you don't really know what you're getting into until you deploy it.
Right, and then you realize, oh, I ended up with 10 terabytes less than I thought I would end up with.
Yeah.
All right, so that's a neat tool to visualize what you're going to present to them.
Yes, and we also want to tell you how many failures you can tolerate, right? In this case, I'm playing with 32 servers. So, I mean, 8 server failures is still a very high number of servers to tolerate, right? So, because I have a large number of servers. Now, this is more relevant. Like if I go back to my toy setup of 4 servers and 4 disks per server, and perhaps I'm only doing 100 gigabytes. Of course, now, with this small as a setup, 4 servers, I can only tolerate 2 server failures, right? That's very small. And if I go with EC4, now I can only tolerate 1 server failure. So it's also good that I understand what I'm getting, right? So that's very important.
That's like your typical setup, living on the edge, right? Kevin,
No failures acceptable.
Kevin likes to live right on the cusp of defeat.
Yeah, but I mean, the good thing is that you understand it, right? So it won't be a surprise.
You know it's
like,
crazy.
Oh,
you're right.
Yeah. Like if you set up this way and you lose 2 servers and suddenly you cannot access your data, you won't be surprised, right?
No surprise.
Yeah. So last thing I'm going to do is just get a review of what's going to happen. We went with pretty much healthy defaults, so I'm not getting much of a review. So I'm just going to hit create, and this is going to generate me a set of credentials, right? So I didn't configure an IDP, so I need programmatic access credentials to access into this instance. This is the only time I'll see them. So I'm going to back them up into my system and then hit done. And now that's pretty much it, right? So now it's going to take a couple of minutes and the new tenant will be up and running, right? So with that, we set up a backup tenant. Now, the MinIO operator is actually provisioning the pods, requesting certificates. Probably if I hit refresh, I'll see that now it's like waiting for some TLS certificates to be issued. It's all of this is automated now, right? So that's pretty much the idea of making it simple and intuitive, right? Everyone can do it on their own, just like they do on the public cloud. Now they can have the same experience on the private cloud. So while that provisions, I'll show you the details of another tenant that I provisioned here. Actually, it shows you, the terabyte tenant that I have, what version of MinIO does it have, and whether the endpoints that I can use to immediately start consuming it and managing it, right? So I can also see that this cluster was originally 512 gigabytes in capacity, and it's already been expanded, right? So we also make expansion very easy, right? And we want to build that story where, the beautiful thing about data is that it scales in a predictable manner. So you can start procuring the next set of servers, bring them to your Kubernetes cluster, and then have MinIO either expand into those new nodes because perhaps you have new locally attached volumes, or perhaps you have some spare nodes because your node is larger, right? Let's imagine that your Kubernetes cluster is 100 nodes wide, and you only use 32 for the first deployment. Perhaps you want to expand another 32 nodes and add some extra gigabytes to your setup, or a few more terabytes, right? So we try to make it extremely easy, right? Just tell us how much you want us to expand, and we'll go on and do that.
Yeah, it looks surprisingly uncomplicated for this world, which, as we said before, sometimes we see these solutions and there's quite a bit more labor involved to get to this point.
Yes. Yeah, and that's something that we realized because we definitely took a lot of time into crafting our object storage in a very minimal way, and we brought a very nice CLI for it. But then we discovered that visual is also like a nice way to explain things, to help people discover things, right? It's easier to explore with your mouse. What are the things that you can do? So right now, what I'm going to show you is actually how to manage one of these tenants. I'm actually going to go into my production storage tenant, and I'll go into the management console for this one tenant. So this one is not protected by an identity provider, so I'll use one of the users that I have on this system. And right off the bat, after logging in, I'm greeted by a bunch of monitoring metrics, right, about the system. This is to showcase our Prometheus integration, right? So MinIO server exposes a lot of metrics regarding its health and status. You can scrape those with any tool you like. Prometheus is an extremely popular monitoring tool nowadays. So you can scrap these metrics, and we offer also Grafana dashboard widgets, which is pretty much the equivalent that we're showing you here. And we're going to tell you what's the state of your storage, right? How much data you're using, the size, the average distribution of your files. And right now, I don't have any activity happening on my APIs, but as soon as we start poking around, if we come back to this screen, you will see a lot of these charts flare up with activity, which is pretty much what's going to happen.
Yeah, it's having the visual display and readouts are always quite handy. It looks like you've got a pretty comprehensive list of data points in here.
Yes, we want to expose important things like letting you know if one of your instances is down, if an individual drive is also failing, right? So these metrics, even though we're right now, you see all this automation is only possible through Kubernetes, but of course, you can also go through the lengths of setting this in bare metal. And in bare metal, you can also bring your Prometheus and collect these metrics, and that's even more relevant, right? You want to know immediately if a drive failed, right? And you can want to set up these alerts as well. Like if there's a failure, MinIO will work with a missing drive or a missing node. We are built to withstand failure. But you want to know about it and perhaps start doing something about it. Like I have to send someone to the data center and fix that. But yeah, that's the whole idea here. And this is the first screen of the management UI for MinIO, right? But you can see that here on the left, I see all the other features that MinIO has. I can go and, for example, I have an object browser that's similar to the previous object browser that we ship with the server, but this one has a little bit more features, right? I can see more of the newer features. I can go through my files and perhaps I can see that, for example, this one file has versions enabled. So I can see previous versions. I can go and download them if I want. I can see if the file has a legal hold or retention policy enabled. I can add some tags to the file. So it's not only about browsing the files anymore. It's also like if we enable any other of the sophisticated features that MinIO has, you can also see them, right, and see what's going on. And perhaps you want to perhaps you had versioning enabled, and you replace a machine learning model, and you want to go back, you want to download the previous version because perhaps it had a better accuracy. So you can pretty much go and do that now. And you don't have to mess with the CLI that much. We just make it visual.
Good. Again, that's my language. Well, that's why when I saw what you'd done with some of the updates to the GUI in this console view, it makes a big difference, I think, in terms of broadening the adoption to making this stuff easier for admins, especially those like perhaps Kevin and I that maybe don't spend as much time with containers. The whole concept can be intimidating, so to give IT admins something like this to manage these things makes a lot of sense.
Yes, and that's our goal, to make it extremely easy for everyone. So
yeah, carry on.
And not only, it's not only about making easy containers or making Kubernetes less intimidating. It's also about making MinIO more friendly, right? So, for example, one of the things that people expect out of MinIO is, to provision buckets, right? So that was the list that I was showing you before. But what does it mean when I'm creating a bucket, right? So I could just name it and be done with it. But MinIO also exposes some other features, right? So backups bucket, right? So I'll create a bucket called a backups bucket, and I probably can enable versioning, right? I was already showing you a bucket with versioning enabled, right? Mm-hmm. Having versioning enabled allows me to do object locking. Perhaps I don't want people deleting files from this bucket just because. Perhaps I have a compliance requirement, right? So I'll set up a retention policy that says, nothing can be deleted for 60 days. Or after 60 days, it will be deleted automatically because that's my compliance requirement. So these are things that you can enable here. Or additionally, for example, I love the quota feature that we have, where you can say, okay, perhaps I'm setting up a multi-user environment, right? I provision a business unit with an object storage, and they're actually sharing the object storage via buckets. So perhaps they want to say, okay, I'll make a bucket for 1 terabyte only. So, and then you give that to a team. If they need more space, they can come back and ask, can you make that bucket larger for me? Yes. Or if this is a bucket for backups, let's say, you can go with the FIFO quota so that the backups never stop, right? You keep pushing backups, and beyond 1 terabyte, we start pushing the older files out of the bucket while you're deleting them. So all of these features can be discovered, and it's easier to discover about their existence if you have a graphical user interface.
Okay. Yeah, it looks pretty, again, pretty comprehensive.
Yes, thank you. So I could go on and show you every single management feature that MinIO has. I'll just show you one more of our latest feature, right? So one of the latest features that we have, I don't know if anyone noticed that before I joined this one tenant, infrastructure was actually telling me that I was not using much of my SSDs, right? I told you this is SSDs, but infrastructure was telling me you're only using 1 gigabyte, about 1 gigabyte. But then my dashboard was telling me you're using 48 gigabytes. So what's going on, right? So what actually I did, because my data is definitely here. I can still browse these files and probably go and download one of these files and get it. But if I go into my buckets, I'll see that I set up a lifecycle management rule for my buckets, right? So this is pretty useful. I'll use why in a moment, right? So here I said everything after a day, anything older than a day, please transition it to this tier, right? I set up a MinIO tier, and I'm having my data automatically being transitioned to that tier after a day. If I go into settings to show you how this tier was set up, it's actually a MinIO tier is of type, is compatible with S3. It's actually the internal URL of Kubernetes that I have for my other tenant. So now it makes sense why I set up a very fast tenant using SSDs, and I have another tenant that's using spinning drives, because I can set up scenarios where I can say, okay, I'll keep the first 30 days, 60 days of production data snappy fast on SSDs. After 60 days, I'll have a transition into a larger and deeper tenant that's backed up by SSD, by spinning drives. And then perhaps after a year or two, I'll have that transition to a entirely different location, right? This is part of our hybrid cloud strategy where you can say, okay, perhaps I want to configure another cloud provider, right? I want to configure some Glacier, right? So data that's aging, 2 years old, I want to send that to a Glacier, right? And I want to just reduce cost this way, right? But we not only support Glacier, we also support, Google Cloud and Azure. So this is part of our hybrid cloud strategy. And we're very excited about this because it unlocks a whole world of possibilities where you can now set up, very fast production tenants that fit your needs. And then, as data starts aging, you can start tiering it down into cheaper tenants. And it's all transparent to the users, right? Users will notice when they go to browse their files and say, I need to download this one file, they won't know that file is coming from a different location, right? We just make it transparent to them.
Yeah, the tiering capability is pretty strong to be able to dump that, as you say, that aging cold data out to, something that's much less expensive, especially if you've got, if you're talking about NVMe tiers, that can add up pretty quickly in some of these cloud providers.
Yeah, but NVMe is extremely attractive because it's so high performant, but then perhaps you cannot afford to build, like a petabyte NVMe tenant. But perhaps, a petabyte tenant on spinning drives might be more affordable. So you can start, first 30, 60 days on NVMe, snappy fast, and then perhaps 6 months data on SSDs. And after 6 months, it goes to spinning drives, right? So you can architect in a way that you get like a really nice quality of service, but also at the same time saving cost.
Are those policies be able to be created automatically, or is it just user set at this time?
This is user setup this time. So when I'm actually managing my buckets, I set up the transition lifecycle transition rules, where I'm saying, okay, after either this specific date or given this amount of days, I want to be able to start transitioning the data out, right? So again, it's something that the user does, not set automatically. We're evaluating being able to set this at infrastructure level, but right now, because we want people to delegate this access. And, the infrastructure guy didn't go to see the data, didn't go to see the buckets, right? Because he's only concerned about, infrastructure itself. Whoever is actually owning the object storage and he owns the accounts, the buckets, and the data that's inside, he'll be more concerned into actually setting up the replication. For example, we also support setting the replication here, controlling access or setting up these lifecycle rules.
So one of the things that you were talking before about when we were going through the tenant setup was the notion of resiliency. And I know that there are some updates in Subnet around health to help do some root cause analysis and keep an eye on the network and drives and all that sort of thing. Is that something you've got available to show us as well?
Yes, of course. So this is the new capability that we have from Subnet So Subnet Health is one of the new capabilities that we introduced where we can actually have you generate a file, right? So via a single command or via the management console, you can generate a file, which then in turn you can bring to Subnet. Subnet is our platform to provide premium support. And pretty much you can say, okay, here's my file. What's going on with my setup, right? So we can help you explore this file and say, okay, this is all the things that we found wrong with your setup, right? There's either a machine is acting up, or the network is slow in this one node, right? Sometimes we've seen customers with challenges. They have very large setups, and then only one node is acting up, right? One node cannot talk to node 63, and they will take them time to figure it out. You can quickly figure out such problems with the Subnet Health platform, right? So even when you bring these files, not only will help you understand your own setup, our engineers can also help you understand and point out this is probably something that you'll want to take care of or look into the future. So this is also another one of the new capabilities that we announced recently.
Yeah, that's another great visualization of these things, and I'm sure it's always networking that's the problem.
You'll be surprised how often it is.
Yeah, everything physical in the data center always breaks because of networking. I'm sure that's the same in these cloud scenarios and Kubernetes scenarios as well.
That is true, but also when you're building distributed systems, right, you go as fast as your slower component. So sometimes one node is slow, perhaps it's one of the disks, right? So if you have one of those very large, very dense boxes that house 106 drives, one could be slow, right? And because he's slowing down whenever you read any file that touches that drive. So we want to tell you this one drive is slow.
Well, Daniel, thank you for running us through all this. I think it's important that a lot of times we have these conversations privately as you go around and demo things for us and other analysts and media. But to be able to take these conversations, put them on video, and share that with a broader audience, we're pretty excited about that, and appreciate you taking the time to walk us through all the new capabilities here.
Sure, anytime.